So today we're going to finish section 1.4. We're taking a look at trigonometric functions and specifically the unit circle. We'll talk a little bit too about how you should sort of expect the unit circle quiz on Friday to look so that you can know how better to prepare for that. But this is the section of material from which that's coming from. So we had taken a look last time at this diagram, and the only thing so far that we had written in is all the angles. And we talked a little bit about the repetitive nature of the way you can think about those angles. On the unit circle quiz, I will not ask you to draw me a unit circle and fill this in. However, there will be a space on there that if you want to fill it in for your own reference to try to figure the rest of it out more quickly, you'll be able to do so. So I think that that's pretty helpful, and so it's up to you if you'd like to do that. So let me remind you from where we were when we were here last time. So all of the angles that are not on the axes, but near them, right? Like near the x-axis, above and below, or near the y-axis on the top and the bottom, all have values that are over the same denominator. So I'll highlight them as I go to draw attention to them. So this one right here, right, and this one, these are both going to be pi over 6 values, right, over 6s. And the same thing for the two that are closest to the x-axis above and below. So it's pi over 6, 5 pi over 6, 7 pi over 6, and 9 and 11 pi over 6, excuse me. And then the ones that are nearest the y-axis are all over 3. So this is pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So that's one thing to keep in mind. The angles that are halfway in between are all over 4. So this is pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay. If you know those angle measures in radian, you can certainly turn them into degrees. You can also just remember the degree measures themselves. So this one is 30 degrees away from 0, and this one is 30 degrees away from 180. So if you go 180 minus 30, you're going to get up. This is 30 degrees away from 180 down, so addition, and then this is 30 degrees away from 360 down, and so you get 330. Whoops, sorry, hit the wrong button. You can do the same thing on the axes that are the ones that are closest to the y-axis. So this one is 60, and then these are multiples of 60. So this is 60 and then 120. We skip 180 because that is the quadrantal angle on the left, okay? And then we come down here and we have another, where is it here, 240. So that's 180 plus 60 is another 240. And then we would have the 300, which is 60 more. So you can keep adding 60s all the way around. And then these are all the 45 degree angles. This is 45. And you can add 45 each time to find the next one. Keep in mind that as you do that, you will end up on the quadrants themselves as you go. So we're at 45. If you do 45 plus 45, you get 90. Plus another 45 is 135. Another 45 is 180. 225, 270, 315, and then 360. So if you think about the patterns that are there, it's a whole lot easier than just flat out memorizing all of this like it is. Like that's a lot, but they're just a repetitive pattern. The same thing is going to happen when we take a look at the ordered pairs on the edges. So this one right here, this is a unit circle. Unit circle means that we have a length of 1 away from the center, right? The radius is 1. So this is the ordered pair 1, 0. So far, so good. As you look at the quadrantal angles, they're all 0s and 1s. This is 0, 1. Over here, we have negative 1 and 0. And then on the bottom, we have 0 and negative 1. Okay, so that's a good place to start. And then all of the other ones are going to have square roots in them. Okay, so we know they're going to have radicals in them. And they're going to have, again, a pattern of what's going on. And the reality is you really only need to memorize the first two, as long as you recognize and see how the pattern works. So let's look at the first two. The first two are square root 3 over 2, 1/2, and square root 2 over 2, square root 2 over 2. And everything else builds off of that. Okay, everything else. So I will move around the circle kind of in an unorganized way because I want you to see where the patterns are. So we'll first fill in quadrant 1. Quadrant 1, this missing one right up here, is actually the one that we just did at the 30 degree angle and it's flipped. Okay, so I take the square root 3 over 2 and the 1/2 and I write 1/2 and square root 3 over 2. Okay, so far so good? Everything else from left to right is a reflection, or from right to left is a reflection. So I have all the same values reflected, and I just need to make sure I get the signs right. So the one that's opposite, the 1/2 square root 3 over 2, is also a 1/2 square root 3 over 2. But one of those is negative. Which one's negative? The x value is negative. And in fact, everything in this quadrant, quadrant 2, will have negative x values. So I have, again, moving around, that was this one. We're on this one now. I have square root 2 over 2 and square root 2 over 2, but the x is negative. And the third one, I have square root 3 over 2 and 1/2, but the x value is negative. Okay, is that all right? So we're going to take quadrant 2 and we're going to rotate it down or flip it down, reflect it down to quadrant 3. And we do the same thing. So quadrant 3, the 210 is going to match the 150. So I'm also going to have the square root 3 over 2 and the 1/2. But what can you tell me about the signs of x and y in quadrant 3? They're both negative, so we put negatives on both of them. Okay, this one down here is going to be a reflection. That was that one, sorry. Move on down here. So this one is going to be the square root 2 over 2's. So square root 2 over 2 and square root 2 over 2. And these are going to also both be negative. And then the last one is going to be the reflection of the 120 angle down. And so I'm going to have the 1/2 and the square root 3 over 2. And again, they're both negatives. Okay. One more time, we can either reflect from quadrant 3 over into quadrant 4, or we can reflect from quadrant 1 down into quadrant 4. I'm going to think about it as 1 down, but you could do it the other way. It wouldn't hurt anything. So if I look at the one that's nearest the x-axis, which is where I'm going to start, it's a reflection of the one nearest the x-axis above it in quadrant 1. So I have square root 3 over 2 and 1/2. But what's negative in quadrant 4? The y. So I'm going to make it negative 1/2. The next one, that pi over 4 type angle, is always going to be square root 2 over 2's. But again, the y is negative. And then down here, I have the reflection from the 60-degree angle, which is the 1/2 and the square root 3 over 2. And again, the y is negative. So filling this in is pretty quick if you remember the patterns. If you go trying to memorize this entire circle without recognizing the patterns, it's a lot more difficult. So I'd strongly encourage you to think about how the patterns work as you take a look at memorizing how this is all set up. So what kinds of questions are you going to actually be asked? Well, you're going to be asked questions like the ones that follow. You're going to be asked questions like, what is the cosine of a specific angle? What's the secant of a specific angle? The tangent, the cotangent, the sine, or the cosine. And it's going to give you an angle measure. The angle measures may be given to you in radians, or they may be given to you in degrees, okay? You can't use your calculator on this quiz, this gateway. On the regular quizzes you can, but not on the gateway. So if you decide, I really hate to work in radians, and I really just want to turn everything in degrees, you can do that. It's going to take you an awful lot longer than if you just learned the radian measures, okay? So as we take a look at this, I'm going to stick with, we're working in radians, we stay in radians, and that sort of perspective as we work. So what I'm going to do as I work through these is I'm going to sort of sketch the image of where I am, but you can feel free to flip back over to here as well in your notes if you're just going to keep them side by side or flip back and forth so that you can look at where we are on the circle. So the first one is we are at 2 pi over 3. So 2 pi over 3 is in quadrant 2. And it's the pi over 3s are the ones that are nearest the y-axis. So it's this one up here. So this is my location. And what I want to remind you, actually I didn't say it at the beginning, so let me flip back and remind you of this from our first slide here that we did last class period, is that the sine value is y, the cosine value is x, secant and cosecant flip those. The tangent value is y over x, and the cotangent is x over y. So we're going to be using that in terms of our ordered pairs. So as we think about this location right here, this location is actually at negative 1/2 and square root 3 over 2. But the cosine value is the, which one, x or y? It's the x value. And what's the x value of that ordered pair? -1/2. And we're done with the problem. So when we're looking at this, we need to make sure we get the right value. Are we looking at x, y, or some ratio of it, right? And we need to make sure we're in the right location on the unit circle. The other thing that sometimes catches people is those signs. So be careful to make sure that if it's negative, you write the negative, or if it's not negative, that you don't, okay? What's that? We only use the x because the cosine value is only the x value. If we were asked the sine value at 2 pi over 3, we would use only the y. Okay, so cosine is the x value, sine is the y value. And if you remember the reason that's happening, because we've talked before about like cosine being adjacent over hypotenuse, is that the hypotenuse is the radius of the circle and the radius of the circle is 1. That's why we don't have to have that piece of it in there. All right, the next one is tangent. I will jot this down as a reminder for us. Tangent is y over x. So when we're looking at this one, we do need the x and the y value for the ordered pair we're looking at. Where is 3 pi over 2?
It's the 270 angle.
Yeah, it's the 270 angle, which is on the bottom y-axis, right? So we're actually down here. I'll mark it in yellow. So if we're at 3 pi over 2, we're all the way over here. And our ordered pair would be what? 0 and -1. So if we do the ratio on this one, the y value is -1. The x value is 0. What happens when we try to divide a number by 0? It's undefined. You can write the whole word out if you want. I'm just going to write u and d. It's an undefined value. Okay, let's try another one. This one's sine. So sine of 5 pi over 4. So where are we when we are at 5 pi over 4?
The third quadrant.
Third quadrant. Okay, so pi over 4 angles are the ones that are halfway in any quadrant, and 5 pi over 4 is this one. So all the way around here is at 5 pi over 4. So our point right here has to be the square root 2 over 2's because that's what corresponds to pi over 4 values. They're always square root 2 over 2. And we need to have them both negative because we're in quadrant 3. Sine is which value? It's y. So I need the y value. So what is the y value of that ordered pair? Negative square root 2 over 2. Okay? One more of this variety. Cotangent of 13 pi over 2. So this is kind of a big number, 13 pi over 2. If you look on your unit circle, you don't see anything that says 13 pi over 2. I'm not going to say for sure if that's the case on the unit circle quiz or not. I don't remember. So let's just say it's a viable possibility right now that it could have an angle that's too big to be there. If we do that, we know how to handle it though. We've been doing that in other sections. We would take our 13 pi over 2 and we would subtract off 2 pi. 2 pi is the same as, 4 over 2, right? It's 4 pi over 2. So if you take 13 over 2 minus 4 over 2, what do you get? Don't everybody talk at once. 9, thank you. So this is 9 pi over 2. That's still too big. I mean, I say too big. It's still not in one rotation. So we would do it again. 9 pi over 2 minus another 4 pi over 2 gives me 5 pi over 2. Still bigger than the values that I have. So you can take 5 pi over 2 minus another 4 pi over 2, and what do you get? That one's there. So where are we on the unit circle if we are at pi over 2?
Top y-axis.
Yeah, we're at the top y-axis on this one. So I end up right here. Cotangent. Cotangent is found by doing what ratio? It is x over y. So this ordered pair right here, what is it? 0, 1. What is x in that ordered pair? And y is 1. What is 0 over 1? It's just 0. It's okay? Sometimes people get a little bit confused where the 0 is the problem. The 0 is the problem only in the denominator. If there's a 0 in the numerator, it's totally fine. You can do 0 divided by something, right? Not a problem. All right, I want to show you a few different features that we will come back to over and over again throughout this semester, and this is sort of our first exposure to some of them. So the first one is even and odd trigonometric functions. So cosine and secant are even functions. Do I need to go back? No, you're okay? Okay, just checking. All right, cosine and secant are even functions. What that means in terms of a graph, and I'll draw you a graph that you're familiar with, that you know that you've worked with before kind of thing. So a graph that you have worked with before that is an even graph is y equal x squared. It's not a perfect picture, but it's not bad. What it means to be even is that it's a reflection over the y-axis. It's the same image on the left as it is on the right. Okay? What that means is all of the x values over here and the y value that comes about on the right side are the same y values that show up on that left side. So if I pick a y value, or an x value, excuse me, of 2 over here, and I pick an x value of negative 2 over here, I'm at the same y value height. Okay, does that make sense? That's what it means to be even, is that it doesn't matter whether the x is positive or negative, I get the same y value. So when I look at the graph of cosine of negative t, or the equation of cosine of negative t, it's the exact same thing as the cosine of t, because it's even. Okay, just like in the picture with our square function. If you put in 2, you get the same value as if you put in negative 2. And the same is true for secant. Secant is actually the same value whether you put in it as positive or as negative. And if you want to, try your calculator for just a second. It doesn't matter what angle you pick. Just pick an angle, 20 degrees, 50 degrees, whatever you want. Put in cosine of that value, and then put cosine of the negative of that. Okay? So let's just do 20. Try putting in the cosine of 20 degrees and put in the cosine of negative 20 degrees. It should give you the same y value. Does it? The output should be the same either way. Okay, that's what even functions do. They are irrelevant of whether or not it's a positive or a negative input. The other 4 functions are what are called odd functions. In odd functions, the input's sign matters. But all it does is it just changes the output to be negative when it would have been positive, or positive when it would have been negative. So a graph that you've seen again before that does this is y equals x cubed. So in the y equal x cubed graph, it looks something like this. And if you put in, say, x equals, I'll just label it as 2 here. And if you put in x equal negative 2 here, you get the same distance away from the y-axis, but it's positive versus negative. All right, so over here you get that this is a height of 8, and over here you get that this is a height of negative 8. Okay, so the number is the same, but its sign is the opposite. And that's what odd functions do. Another way to describe what odd functions do is that they're a rotation around the origin. Right, so if you take it and you rotate it 180 degrees, right, from the top to the bottom, right, kind of like a spinner on a game board, it will rotate and it will land right back down on itself. So this piece down here will flip up to over here and vice versa. Okay, so that's another way to think about it, is it's got origin symmetry. So what that means in terms of all of our trig functions is simply that if we have the sign of a negative value, it's the same thing as doing the sign of the positive value with a negative on the outside. Now, we have not sort of plucked it out and put it out there, right? It looks like that, but it's not a feature of all graphs. It's just for sine and cosecant, tangent, and cotangent. T is not the best letter, but it's the one I picked, apparently. Probably was what your book did. All right, so we have these cosine and sine values and so forth, and they have these properties. Okay, so cosine is even and it's reciprocal. Sine and tangent are odd, as are their reciprocals. So let's take a look at our last couple of examples. This one says we're going to use the unit circle to find the value of the trig function. Okay, so this is the same thing that's going to be on your unit circle quiz. And then part B says to use, or the second step says to use even and odd properties and the answer from A to decide what the answer is for B. In other words, if you had started here, how would you utilize this information to find the answer instead of going back to the unit circle to start with, okay? Or to continue with. All right, so pi over 3. Where are we if we're at pi over 3? We're in quadrant 1. Are we near the x-axis or the y-axis? Y. Pi over 3s are always near the y-axis, so we're up here. And we have an ordered pair here of what? Yeah. And because we're in quadrant 1, everything's positive, so that's very friendly. So cosine. How do I use the x and the y to find what the cosine value is? Well, what is cosine? Cosine is just x. Okay, so all I need is the x value. Okay, so this is something, remember, I mentioned this last time, I'll mention it again too. I remember it because it's in order. Cosine comes before sine in the alphabet, C before S, and x comes before y in the alphabet, x before y. So cosine and x go together, sine and y go together. That is how I learned it, and that's how I continue to think about it. So what is the x value of this ordered pair? 1/2. Now, technically, I could do part B and start over from scratch. I could make sure that I'm at negative pi over 3. So it's pi over 3, like I did, but I would go backwards on the unit circle. I'd go down into quadrant, I'd go backwards on the unit circle, back down into quadrant 1. And I didn't say it right. Instead of going into quadrant 1, I go into quadrant 4. That's what I wanted to say. So, I mean, I could start this from scratch, and I could draw this out, and I could recognize that I'm supposed to be, sort of down here and go with it that way. That's what I could do. There's nothing wrong with that, and I won't know if you did that, right? Like, there's nothing here that says, like, if you did that, you're doing it sort of wrong. That's not really what the directions are wanting us to think about, though. They're wanting us to think about even and odd properties, and the reality is it's easier to do so. So cosine is an even function. The even functions have the property that whether the inside's positive or negative, I get the same cosine value. So over here, when I'm looking for cosine of negative pi over 3, it's the exact same thing as the cosine of pi over 3. So I'm not ignoring the negative. I'm not. I'm remembering that there's a property that says these things are equal. Okay? So if I do cosine of pi over 3, I will have the same thing I did on part A, and my answer will again be 1/2. Okay? I want to show you a couple more things that might be helpful for the unit circle, and then we'll end a little early today. Okay? If you take a look back over here at the examples that I did on the previous page, I did cosine, tangent, sine, and cotangent, and I didn't do anything with cosecant or secant. So I'd like to take a look at the unit circle from that perspective with secants and cosecants, just because we didn't do one. Sound good? Okay. So if I were looking at, oh, that's a terrible backdrop. Let's make it at least darker so that I can see it against the screen. All right, we'll do black. So let's say that I was looking for the secant. Is that readable? It's not too bad. It's okay? Okay. Let's say I was looking for the secant of 3 pi over 4. And so we'll do this one. This is like number 7 on our list. And for number 8, let's do the cosecant of, let's see something interesting maybe use. Let's do 330 degrees. Yeah, that'll be fine. We'll see if those do what I want them to do. If they don't, I'll create another one. It's not a big deal. All right, secant of 3 pi over 4. So where are we if we are at 3 pi over 4? We are at 135 degrees. Which quadrant is that, Chloe? Yeah, we're in quadrant 2. So we are over here. and the 45-degree angles cut things in half. So anytime we get things that are over 4s, we're in these sort of halfway spots, and the ordered pairs that they come about are going to give you square root 2 over 2s. But I'm in quadrant 2, so there's going to be some signs that are not positive here. What's not going to be positive? X. So the X needs to be negative on this. Okay, everybody good so far? Okay, great. All right, if we're doing secant, what is secant? Well, it's the reciprocal of cosine, right? So this is the reciprocal of cosine. And cosine's value here is what? It's the x, right? It's the x value. So if I take this value, there's two ways to do this. We could remember that secant is 1 over x, and we could write this as 1 over the square root of 2 over 2, and then we could simplify it. I don't think that's our cleanest way to do this particular problem. I think it's cleaner to remember that the cosine value is the x value, and I find it's reciprocal just by flipping it, because then I don't have fractions inside of fractions. So if I remember that, then I'm going to have 2 over square root 2 here. If you remember it to do it as 1 over x and do it that way, it's fine. You're just going to have one more step than I'm going to have to show because of where you're starting. You don't get to leave square roots in the denominators. We've already talked about that in a couple of different class periods. So we're going to multiply the denominator by square root of 2, which forces the numerator to be multiplied as well. So now I have 2 square root 2 on top, and I have a 2 on bottom. I have missed one thing so far. What have I missed? My negative. So I need to go back and do that because I did leave that off by accident. So I want to put that in. It is the negative 2 over square root 2. And then what do you notice here? Yeah, these two cancel, right, when I'm doing my rationalizing. So my answer just ends up being negative square root 2. So it is often, though not always, the case that when we do our secant, our cosecant, and our cosine, and tangent sometimes too, but we may have to do some kind of rationalizing of the problem. Okay, we may have to. Let's see what happens with the cosecant of 330. So where are we if we are at 330 degrees? Quadrant 4. Whereabouts in quadrant 4? Yeah, at the 330, we're actually close to the x-axis, right? Okay, so we're right over here, closest to the x-axis. And what's the ordered pair right there? Yes. And you got the negative in there. So yes, so we're making sure that our y value is negative. We have square root 3 over 2, and then we have the negative 1/2. Okay, so cosecant is the reciprocal of what? It's the reciprocal of sine, and sine is which value? Y. So my y value here actually happens to be the more friendly of the two. It's the one that doesn't have a radical in it this time, so that's lovely. So if I have negative 1/2 and I flip it, what do we get? Negative 2. So this ends up being negative 2. If you're thinking about this as I need it to be 1 over y, let me show you what that looks like, if that is what's sort of making more sense to you. You'd have 1 over, and then you'd have negative 1/2 like this. And then you'd have to multiply by the reciprocal. It would cancel everything on bottom, and you'd still end up with a negative 2 on top. It just takes about a step more to do so. Okay? All right, that's where we're going to end today.